Welcome back, chemistry fans. Today we are going to do the density lab. And it's a very, very simple, but a very, very frustrating lab to collect data from. So it may take a few tries to get your data. It also is going to take patience because I only have 10 of those syringes and there's 12 of you groups. So be patient if you're the odd man's out. Please help and make sure you notify other people once they have gotten to that point that they have access to them. Okay, so let's jump right into it. Let me switch my cameras. Okay, what you see is a very fancy balance that you will have access to, and you also have the syringe over here with a cap. And these are a squished version of the syringes that we have previously used. So that's okay. We're going to show you how to do this. Now, on top, there is a sliding door, which will give you access. And what this does is if you notice your scale, your balance, it has more zeros than the small balances that we've been using throughout the year. So this is going to allow us to get more accurate readings. Our goal is to measure the amount of carbon dioxide in this and try and calculate a density. So let's take a look at my page here and let's figure out now what is the formula for density. Density is equal to mass over volume. Okay, well, we are going to calculate the mass because you notice the units are in grams, and we can calculate a volume because we know that right here. So that will allow us to calculate a density. Awesome. All right, so here we go. Here's the procedure. So you're going to take this very funky looking balance. You're going to take your syringe and you're going to squish everything out. If the cap is on, it's not going to squish out. You're going to be frustrated because it's stoppered. So make sure you take the cap off, squeeze it all out so there's no gas collected in there. Put the cap on, move the opening on top, and place the syringe in, close the opening, and then get your measurement. Now, what you can do here, if some of you notice, is you could also you could zero this out. You could push the tare button, although it says tar. They couldn't put that E on there. So you could push the tare button if you wish. But my guess is that this one fluctuates, though the weight of gas is not very much. So it's probably going to be better if you just write down the value. Okay, so here we go. Next, we're going to open our door back up. Whoop. We're going to open our door back up. We are going to pull out our syringe, and we're now going to fill this with gas. Only going to be able to fill it to about 30 milliliters. That's where the top of the plunger is, and you're going to cap it. Now, what is it sucking up in there? It's sucking up mostly nitrogen air. Now, if you wanted to, you could blow in there carbon dioxide, but mostly what we've got is nitrogen. It's 80% nitrogen. Carbon dioxide would be even lighter. So we probably don't want to even put our mouth on the syringe because we would only have a weight of like 18. So nitrogen is going to be a little bit heavier. And if some of you want to do the math to figure out 18% oxygen, 80% nitrogen, we could do that. We're going to place it back in, and notice I put it at 30 milliliters just so that lid will go right past the syringe. If you put any more than 30 milliliters, it's going to change. All right. Now, here's where it gets frustrating, is the gas is somewhat lighter, and so it went down in weight. It should have gone up, but it's probably elevating it just a little bit, and it's causing it to have a little bit of buoyancy. And so the weight tends to go down, whatever the difference of the values is. And if you notice in mine here, I've got a difference of 0.002, whatever the difference is. If it's positive or negative, just make it absolute value, and let's go with what we've got. This is an imperfect science. Go with what you get as the difference between them. And then we're going to use that as our mass. Our volume is equal to 30 milliliters. So this is in grams and milliliters. We are going to calculate mass divided by volume to give us our density. So you're going to take those two values, get your answer, and I want you to Google not goggle, Google your answer. Google your answer and compare it. So I want you to come up with a percent error of what your density is compared to the density of nitrogen or of air, whichever you are going to use. So I don't know what your answer is, but I want you to calculate it and then compare it and get me a percent error for the calculation of the density of a gas. This shouldn't take you very, very long. So I hope that you will be able to handle this. Thank you very much for watching. I'm sorry I'm not there today. I will hopefully get to come with you next year and we can do a fabulous adventure together too. Thank you very much. I got to see you. Love you guys. Bye.